wire. Now these wires run a long distance. Ji bete, Mustafa, you have raised your hand. You want to ask something?
सर ये एक अर्थ वायर भी तो होती है.
बेटे आ रही है अभी अर्थ वायर वाला पार्ट जहां पे आएगा वो करेंगे. अभी हम अर्थ वायर को we won't bring it from power generation plant. So that will come to us at the point where we are going to deal with this household electrical circuits, real electrical circuits.
ठीक है.
So I'll bring it over there, not over here. Now, then we have this part. Okay, now at this point, we are going to have another transformer, and this is a step down transformer. So then we have a step down transformer. And this is how I'm going to present the step down transformer.
ये आपने ट्रांसफार्मर को शो करें जो अभी बना रहे हैं.
See, these are the symbols of transformer. I'll label everything that I'm making over here in the diagram. Okay, the next step is, again we have a whole length of a live wire. So I'm showing you the live wire and a whole length of a neutral wire. So this is a neutral wire. So we have a live wire and we have a neutral wire. So these are the parts. Now, from this point, I'm hanging through parts over here. And at this point. And then I'm going to make an elaborated formation of one of the circuit, which I've shown you over here. Now I'll bring that, what you call the earth wire at this point. It's a whole lengthy diagram if you want to really understand this circuit. That's why it will take some time today. But once I'll make this part, then it will become easier for you to understand. And actually, you'll become a good person who can deal with the household electricity. But I won't recommend you because you are not having any practical experiences. But at least you can understand when the electricians are working at your places, that how they're working and how they're putting their efforts and what they are actually doing in connecting your circuits when you call them. Okay, guys. So this is right now for your understanding. I've made this whole circuit. Now we are going to learn about this whole circuit, that how this circuit works and how we have begun from this point that we call the main practical circuits. First of all, I'll bring it over here, starting from this very point, and I'm going to label them each of the section. So the first part is electrical power generation plant. Electrical power generation plant. For example, hydroelectric power plant or nuclear power plant. I'm just writing it down here so that you can get to understand. Let's say that we have hydroelectric power plant, and nuclear power plant, and etc. So I'm just making one of them over here. Then this generates electricity, and it has two wires. The red wire, which I've made over here, it's actually the live wire. So this wire is the live wire. And this wire, I'm going to name it as a neutral wire. This is a neutral wire. Now, this whole thing, which I've made over here, it's actually an official symbol of transformer. And this is a specific type of a transformer, which is named as step-up transformer. Then we have another part over here, another type of a transformer that I'm naming as step-down transformer. So I'm labeling it over here. I'm just going to write it labels once I'll done marking them. Then each over here is basically a consumer unit. So this is the consumer unit. This, and also this one. All these are the consumer unit. That means that I'm talking about us, our houses, a building. So all those parts are basically consumer units. So this is also a consumer unit. But this is an elaborated form of the consumer unit so that we can understand that how consumer units are working. So I've shown you the elaborated circle of a consumer unit. That means that this and this they all are same, but one of them is just an elaborated form of the consumer units. So I'm marking over here. This is an elaborated form. Okay, so now I'm going to label them as I just mentioned. In the consumer unit elaborated form, I'm going to add the earth wire. I haven't added it right now, but I'll add it later on. Now, this is the live wire. I'm going to define each of these components, which I have marked over here. This is neutral wire. Then this is step up transformer. Then we have this, which is a step down transformer. Then over here, these are the consumer units. And this very image, the diagram, it's an elaborated formation of a consumer unit. Elaborated circuit of consumer units. Okay. A few more labels I would prefer to add over here. Number one, this electricity meter. Then this as fuse. This as switch. And we have this as a load. So this is a load. I'm going to label them fuse, switch, load, resistor or a load, and this is an electricity meter. It measures the unit of electricity that we are using. Okay, Vijay. Now I've brought this whole thing in one space so that now we can talk about that. Acha. Okay, guys. First of all, what is a live wire and how these things are going to work? Live wire, once electrical energy is being converted from non-electrical energies, like from hydroelectric and kinetic energy, in nuclear, it's nuclear energy which is converted to electrical energy. So once we have converted these forms of energies to electrical energy, they cannot be stored because electrical energy cannot be stored in this case. So we need to supply it immediately to the consumer. Now, in order to supply it, we require connecting wires. And the connecting wires that we are using over here, they are the copper wires, with one wire is named as a live wire, which is actually carrying current, and it is at a high positive or negative potential. That means that this is the actual wire which is carrying large amount of current, and it is at high electric positive or negative potential. That means that the charge flowing through a live wire is the charge which is actually possessing energy, electrical energy with it. Because we know that for the flow of charge, we require electrical energy. Remember this part? That for the flow of charge, electrical energy is required. So that I'm saying the live wire is a wire which is actually carrying current. That means that it is carrying charge, and this charge is carrying energy. It is possessing energy. Now, this is the very energy which when passes through, this charge when passes through any electrical component, for example, a load, then it will supply its electrical energy, or it will transform its electrical energy to non-electrical energy in order to do work to pass through that electrical component. And in doing so, that electrical component can be switched on and it works as per its requirement. For example, if it's a light bulb and this charge carrying electrical energy passes through the light bulb, it converts part of its electrical energy to non-electrical energy. That means that light energy or heat energy, and the bulb will give us light. So that means the live wire, which is carrying charge, which is actually possessing energy. So now I'm going to write over here that live wire is a wire at high positive or negative potential. A wire live wire at high positive or negative potential. High positive or negative potential. Usually live wire, the actual color of the live wire, I'm just telling you, adding up to your knowledge, it's basically brown color, but you don't need to remember the color scheme of the live wire. So the standard color for the live wire is brown color. Brown color. Then we have the second part, and just for your knowledge, that this is the wire which carries current. Just a second, Mustafa. Current to the electrical component. Yes, Mustafa, now you can speak.
सर नेगेटिव पोटेंशियल का क्या मतलब है?
At your level, because this is something that you will study in real detail in A levels. At your level, we are not typically discussing the negative electric potential. But say, for instance, that you needed some money and you don't have it, and I'll give you like $100. You don't have these $100 at all. So you are carrying $100 with you, that you have some worth, but actually that $100 are the debt, is a debt that I have given you. So that means that you are in negative. Do you understand this concept?
Yes, sir.
You have taken a loan. Actually, that loan is with you. Those $100 are with you. You can spend them, but at the same time, that is a loan. So you are practically in negative amount because you have to, at one time you have to repay it. Now, when charge comes out of a power source, they don't have anything with them. They don't have any energy, practically. So, an external source, when non-electrical energy is converted to electrical energy, is providing them with that energy that we call the electrical energy that charge possesses. and due to that, it can do work. So it's not practically belonging to that charge. Somebody else has given that energy and charges in the loan, which the charge has to pay back. And how the charge is going to pay back that loan? By moving and using that energy to do work and return to their position at the end from where they have begun. So practically, whatever electrical energy is possessed by a charge at any given point, it should be in negative. And it becomes less negative, the more the charge work and the more the charge covers a distance, and then it comes back to its original point from where it began. Are you getting my point?
Yes,
So,
sir.
practically, we are not discussing the practical thing in terms of numerical with you guys, but still, the reality is this which I have given you. The reality is that you need to understand that the potential that current is carrying in it is actually a negative potential, which means that it's actually carrying energy at this point. So, wire which carries current to electrical components is basically the live wire. Then we have another part over here, the neutral wire. Wire at 0 or lower potential, lower electrical potential. So this is a wire at lower electrical potential, and this is the reason why current is actually flowing. Now, just think that you are living on one side of a river bank, and this is highly populated river bank side, and the other side is least populated, or it's not at all populated. There are no construction, none of the human beings are living on the other side of the river bank. But you don't have any option to move to other side, because the river is quite wide, quite deep. You don't have boats, you have nothing else with you, you don't have any bridges or flyovers to cross the river. So that means that you cannot move from highly or densely populated area of the riverbank to the other side of the riverbank, which is not at all populated. But if somebody brings a flyover or constructs a flyover in between the two riverbanks, then what will happen? Large number of people start emigrating to that side of the riverbank, which is unpopulated, where there is nobody living, so that a balance can be maintained. So the more the difference between the populations of one side and of the other side, the more will be the transfer, immigration of the humans from one side of the riverbank, which is highly or densely populated, to the lower side. But consider that once both sides are equally populated, now only people which are actually needed to go there, only those people will go there, not everyone. So that's because of some sort of a work or some sort of a job or something like that. Now, in the similar manner, current always need that difference. Charge possessing energy at one point will only transfer to another point if that point over there charge is not carrying energy at all, or it's carrying energy lower than the energy at this point. For example, if in a circuit I have one point where 1 coulomb charge is carrying energy of 10 joules, that means that at that point electrical potential is 10 volts. I'm repeating my concept that if at one point, any given one point in a circuit, 1 coulomb charge possesses 10 joules of electrical energy, it means that that point's electrical potential is 10 volts. Now there's another point in a circuit where 1 coulomb charge carries zero energy. So that means that the electrical potential of that point is 0 volts. Now, initially, these 2 points are not connected by any connecting wire or any resistance or any bridge in between them. So that means that no current can flow through point A to point B. But once I'll connect a resistor, for example, a light bulb, in between, because that light bulb is just like a bridge. Consider that it's just like a bridge, but this light bulb won't let current charge to flow through it until you will pay the toll tax. Like for example, that you have to drive on the motorway or on a ring road or on several places which are the flyovers over the bridge, over the river. So you have to pay the toll tax. In the similar manner, the light bulb placed in between the path of these 2 points, it is a bridge, but only it allows that charge which will pay a toll tax. And that toll tax is in the form of electrical energy. So now we have 2 points A and B. Charge at A possesses 10 joules of electrical energy, means that it has electrical potential of 10 volts. Charge at B possesses 0 joules of electrical energy, that means that the potential is 0 volts. Now I'll place a bulb in between them and connect the 2 points. Now the charge from A can move to B, and the reason is that they want to move to the least populated area. That means that the charge want to move to the point where there is lesser energy. So now, in order to pay them, in order to move to that point, the only option left with the charge is to use all or partial or fraction of its energy. There are different possibilities. That the charge may use all of its energy, electrical energy, to do work, or it may use a fraction of its energy to do work and to pass through the bulb and to move to the point where there is lower potential. And in doing so, it will convert its electrical energy to the required energy. In case of bulb, that's light and heat energy. So the bulb will glow, it will give us light. Now, that's what is live and neutral wire. A live wire is a wire which is at a higher electric potential, and a neutral wire is a wire which is at a lower electric potential. Wire at higher electric potential, positive or negative, is named as the live wire, and wire which is at a neutral, zero potential or low potential is named as a neutral wire. Now, any component that we want to switch on, we need to place them, we need to connect that component in between live and neutral wire, so that current can flow from live wire to the neutral wire via that component, paying a toll tax in the form of electrical energy, which that component will convert to non-electrical energy and will perform its function. Is it clear? बच्चे, ये बहुत important explanation है. अगर किसी को ना समझ में आई हो तो please let me know. And if you want in any other language, I don't promote that. I won't encourage. तो अगर आप चाहें तो मैं जो languages मुझे आती हैं, मैं इस concept को उन सब में repeat करने को तैयार हूँ. आपने hesitate नहीं करना है, मुझे बताना है.
तो उर्दू में बता दे जरा.
उर्दू में बता दो. अच्छा.
नहीं सर, साथ को पंजाबी में बता दें.
नहीं बेटे, मुझे फ्रेंच भी आती है honestly थोड़ी सी. If you want, I can teach in French as well. So the point is, आसान अल्फाज में बता देता हूँ. Live wire, it's a wire जिसमें जो चार्ज होता है ना, उसके पास एनर्जी होती है. और न्यूट्रल वायर इज अ वायर जिसमें चार्ज जो होता है उसके पास एनर्जी या तो ना होने के बराबर, या तो होती ही नहीं है या फिर ना होने के बराबर. अब ये दोनों वायर्स का कॉम्बिनेशन क्यों जरूरी है? वो इसलिए जरूरी है कि हम अगर ये एक हायर एनर्जी वाली वायर और एक लोअर एनर्जी वाली वायर नहीं रखेंगे तो करंट के फ्लो करने का कोई लॉजिक डेवलप नहीं होगा. जब भी हमने किसी इलेक्ट्रिकल कंपोनेंट को स्विच ऑन करना होता है तो हमें उसमें से करंट का फ्लो करवाना, चार्ज का फ्लो करवाना जरूरी बन जाता है, ताकि जो चार्ज अपने अंदर एनर्जी रखे वो उसको कन्वर्ट कर दे इलेक्ट्रिकल से नॉन इलेक्ट्रिकल में और वो डिवाइस अपना फंक्शन परफॉर्म कर सके. अब फ्लो करने का इस the whole universe has one law that कहीं से भी कोई भी चीज एक्सेस में होगी, it will move to the point where it is in deficiency. So in case of a live wire, चार्ज के पास एनर्जी ज्यादा है और न्यूट्रल वायर में चार्ज के पास एनर्जी नहीं है। तो चार्ज को जैसे ही एक पाथ मिलेगा, बेशक वो पाथ किसी इलेक्ट्रिकल कंपोनेंट की फॉर्म में क्यों नहीं है, कोई एयर कंडीशनर है, रेफ्रिजरेटर है, बल्ब है, फैन है, कोई भी ऐसी चीज है, वो एक ब्रिज बन जाता है लाइव और न्यूट्रल वायर में हायर और लोअर एनर्जी वाले के दरमियान। तो जैसे ही हम उसको लगाते हैं, स्विच ऑन करते हैं, ब्रिज पूरा हो जाता है, चार्ज हायर यानी लाइव वायर से मूव करके लोअर यानी न्यूट्रल वायर में जाता है। अब उसे पास करने के लिए वो इलेक्ट्रिकल कंपोनेंट कहता है कि आपके पास जो एनर्जी है उसका टोल टैक्स पे करो। चार्ज के पास कौन सी एनर्जी थी? इलेक्ट्रिकल। वो टोल टैक्स मांगता है कि इलेक्ट्रिकल एनर्जी दो। वो जितनी इलेक्ट्रिकल एनर्जी को कन्वर्ट कर देगा किसी भी और फॉर्म में, उतना ही चार्ज वर्क डन करके उस जगह से पास कर सकेगा, जिसे हम बोल देते हैं रेट ऑफ फ्लो ऑफ चार्ज, करंट। क्लियर है बात? तो इसका मतलब है कि करंट फ्लो कर सके। और वो
अगर बल्ब से पास कर दे चार्ज, तो उसके बाद फिर वो न्यूट्रल वायर से फिर दोबारा पास करते हैं ना एनर्जी लेने के लिए, वो उसका जो सोर्स होता है।
आप समझ लें कि फिर वो न्यूट्रल वायर से चार्ज वापस जाएगा पावर जनरेशन प्लांट पे, वहां से फिर एनर्जी लेके आएगा।
सही सर, सही।
The system is going on like that.
क्योंकि सर चार्ज के पास एनर्जी होती नहीं, वो ट्रैवल फिर कैसे कर लेता है वायर के थ्रू?
Can you repeat this? Speak a bit louder, please.
सर मैं पूछ रहा हूँ कि जब चार्ज के पास एनर्जी खत्म हो जाती है तो फिर वो न्यूट्रल वायर से दोबारा पास कैसे कर लेता है प्लांट?
100% खत्म नहीं होती है। देखो हमारे पास we have several electrical components. It's not necessary that whatever total energy is carried by the charge, the whole energy is given to that electrical component. I've told you in the very beginning that whatever energy charge is carrying, there is a possibility that all of that energy is converted, or partially fraction of that energy is converted. And practical grounds, and on practical grounds, there is always that fraction of energy left with charge with which it can use and can flow through that connecting wires as well. The connecting wires offer very small resistance, but still they offer some resistance, and for that we need charge to do work. And in order to do that, charge possesses a small magnitude of energy that is required to flow through that. Is it clear?
Yes sir, ठीक हो गया।
अच्छा बेटे, now I'm coming back to this point. मैंने आपको जो भी कॉन्सेप्ट समझाए, अभी मैंने इसमें बहुत डायग्राम्स समझाने हैं। It will take 2 more lessons to complete the whole electricity portion. This is the last part. ठीक है? Okay. अब हम आते हैं इसके अंदर कुछ लेबल्स मैंने फर्दर आपको शो करने हैं। And for that I need to zoom in. Now, as I have labeled this as live wire, so I'm going to place potential, electrical potential, just for our knowledge, electrical potential at this point as making it 500 volts. Right now I'm considering that the electrical potential at this point is plus 500 volts, and the electrical potential at this point, this is a neutral wire, is 0 volts. This means that the potential difference between these two wires is 500 minus 0, which makes up 500 volts. This is the potential difference. So I'm marking it as a potential difference between these two wires. Now, there is a specific purpose of a step-up transformer. But before telling you that purpose, defining you that purpose of the step-up transformer, I would just like to add up the transformer is an electrical component. I'm going to write the definition of this. Don't worry about that, but rather we have to study the whole mechanism of the transformer, that how transformer actually works. But right now, just you can, for your understanding, we can say the transformer is an electrical component which can transform smaller voltage at higher current to higher voltage at smaller current. Low voltage at high current to high voltage at low current और vice versa. एक ऐसा इलेक्ट्रिकल कंपोनेंट है जो कम वोल्टेज को ज्यादा पे कन्वर्ट कर सकता है, लेकिन जब वोल्टेज कम होगी तो करंट ज्यादा होगा, और जब वोल्टेज ज्यादा होगी तो करंट कम होगा, या ज्यादा वोल्टेज को करंट कम वोल्टेज पे कन्वर्ट कर सकता है, बट ज्यादा वोल्टेज होगे तो करंट कम है, और जब वो कम वोल्टेज पे करेगा तो करंट ज्यादा हो जाएगा. That means that there is a combination of voltage and current. But the main point is that transformer is something which can convert low voltage at high current to high voltage at low current, or vice versa. That means that high voltage at low current to low voltage at high current. So this is the function of transformer. Now we have a transformer over here. I'll write down the definition of transformer, don't worry. Now, according to that, because it's a step-up transformer, so once I'm considering it a step-up transformer, I'm going to write the potential difference across this part, and let's make the potential of this part as 5 or 10,000 volts. Rather, I'll make it 100,000 volts. I've increased the potential of this live wire to 100,000 volts, but this wire stayed at 0 volts. So what is the potential difference in this case? 100,000 minus 0 means it's 100,000 volts. So the potential difference across these two is 100,000. Vijay, can you tell me the? Okay, we left it 5 minutes. Okay. The whole diagram is the thing that we are going to discuss along the whole topic of practical electricity. So I'm dividing this diagram in different sections, which we are going to study. So now, अब हमने लगा दिया 100,000 volts. अब इस पॉइंट पे आते हैं और मैं वापस पहले ट्रांसफार्मर की डेफिनेशन आपको लिख के दूंगा, and then I'll tell you that what is the purpose of step-up transformer. Transformer. An electrical component which can convert large voltage at small current to low voltage at large current.
मतलब सर पे करंट को मेंटेन करने के लिए ये होता है?
नहीं, वोल्टेज को वेरी करने के लिए होता है, वोल्टेज और करंट को, और वाइस वर्सा. वैसे have you ever used transformer in your life, daily life? Have you ever used transformer? Vidya ji, have you ever used transformer in your daily life?
सर खुद का पता नहीं, घर तो वही सीढ़ी
louder please, louder Abdul Rafi.
सर घर का तो पता नहीं, लेकिन जो स्टेप डाउन ट्रांसफार्मर से नहीं घरों के अंदर आती लाइट,
कोई नाम दे सकते हैं आपने घर पे यूज किया हो ऐसे स्टेप डाउन ट्रांसफार्मर?
ऐसे नहीं
बेटे,
पता।
आप लोगों की लाइफ में कोई ऐसा दिन नहीं है जिस वक्त आप स्टेप डाउन ट्रांसफार्मर के बगैर रह सकते हैं। आपके मोबाइल के चार्जर्स, आपके लैपटॉप
स्टेबलाइजर हो सकते हैं,
जी बेटे,
स्टेबलाइजर्स हो सकते हैं।
बिल्कुल, स्टेबलाइजर्स भी ट्रांसफार्मर्स हैं, चार्जर्स भी ट्रांसफार्मर्स हैं। There is not single day of your life that you can live without transformer. आपका मोबाइल ना चार्ज हो तो क्या होगा बेटे, आपको पता ही है, ठीक है? So all these are transformers. They can convert. Stabilizer is a very good example. They convert large voltage to small voltage. So now I'm going to write just the type. Next class we are going to study the formula that we are going to apply in transformer and why we are using step up transformer. So that's a part which is related to the next class. Two types. Number one is,
सर मैंने एक क्वेश्चन पूछना था आपसे।
जी बच्चे पूछे।
सर ये नहीं समझ आई, लार्ज वोल्टेज या लो करंट एंड लो वोल्टेज एंड लार्ज करंट, ये क्या सर, ये लिंक नहीं समझ आई मुझे।
बेटे आप मुझे बताएं कि आपके घर में जब वोल्टेज आते हैं तो वो 220 वोल्ट्स होते हैं ना?
यस सर।
लेकिन आपके मोबाइल को जो वोल्टेज मिलते हैं वो कितने होते हैं?
वो कम होते हैं सर।
मोबाइल किस तरह वो वोल्टेज हासिल करता है?
कम कर लेता है सर।
चार्जर लगा के, चार्जर के अंदर से अगर आप खोल के देखेंगे ना, यू विल फाइंड अ ट्रांसफार्मर। वो क्या करेगा, ज्यादा वोल्टेज को कम पे चेंज कर सकता है।
ठीक है सर।
और ऐसे भी ट्रांसफार्मर हैं जो कम वोल्टेज को ज्यादा में भी चेंज कर सकते हैं। सो अब मैं
दोनों में नहीं होगी तो सर, अगर लो वोल्टेज आ रहे हैं इसको ज्यादा में चेंज कर देगा।
बेटे थोड़ा सा ऊंची बोल देंगे प्लीज, करीब करके।
तो मैं कह रहा हूँ कि अगर लो वोल्टेज उसको ज्यादा में कैसे कर लेगा, वो तो सर
बेटे वही तो मैंने आपको अभी तो बताया कि दैट इज अ पार्ट ऑफ अ नेक्स्ट क्लास। आते ही मैं पहले कुछ कैलकुलेशन करके दिखाऊंगा, आपको एनर्जी, कंजर्वेशन ऑफ एनर्जी का रेफरेंस दूंगा, and then I'll give you the idea that how low voltage can be stepped up or large voltage can be stepped down.
थोड़ी एनर्जी को ज्यादा में कर लेते हैं, वोल्टेज को थोड़े वोल्टेज को ज्यादा में कर लेते हैं। एग्जांपल है
बेटे, it cannot increase energy. Energy stays same. Remember that fact.
वोल्टेज का पूछ रहा हूं, करंट जो है।
I don't know that my speakers are working properly, but your voice is too low to understand, or it's like you're not using something.
मैं एनर्जी का नहीं पूछ रहा, मैं पूछ रहा हूं वोल्टेज, जो वही वोल्टेज और करंट है वो उसको कैसे, एग्जांपल है कोई थोड़े से वोल्टेज।
मेरे बच्चे मैंने यही तो चीज समझानी है। जो ट्रांसफार्मर का मैकेनिज्म है ना कि ये काम ये कैसे करता है, ये है मैग्नेटिज्म के पार्ट में, इलेक्ट्रोमैग्नेटिक इंडक्शन में। उसमें तो बहुत खुल के समझ में आ जाएगा, हमारा अगला पोर्शन वही है। लेकिन ऐसा नहीं है कि हमें वहां तक का वेट करना होगा। मैं नेक्स्ट क्लास में ही आपको ये बात बताऊंगा कि ट्रांसफार्मर ये काम करता कैसे है, ऑन द ग्राउंड ऑफ दिस व्हाट वी कॉल न्यूमेरिकल बेस्ड एंड एनर्जी कॉन्सेप्ट। अभी सिर्फ मैंने आपको बताया है कि ये करता है, हाउ इट डज दिस फंक्शन, हाउ डज दिस परफॉर्म इट्स फंक्शन, दैट इज अ डिफरेंट सिनेरियो। वो मैं आपके साथ नेक्स्ट क्लास में डिस्कस करूंगा। अभी के लिए सिर्फ और सिर्फ मैंने आपको सिर्फ ये चीजें शो की हैं ताकि हम इंट्रोडक्शन पे आ जाएं प्रैक्टिकल इलेक्ट्रिसिटी के, that how these things are working, how we are using these practical circuits and how this whole thing is working together. ये सिर्फ मैंने अभी शो किया। अच्छा बच्चे, क्लियर है? तो अभी इसके फंक्शन को बताना है, डोंट वरी अबाउट दैट, I'll elaborate it in the next class. Okay guys, for now it's done. Inshallah we'll see you on Monday related to this part. तो फिर मैं आपके साथ इस पे फर्दर जो है I'll go for the discussion of that. Thank you so much. Allah Hafiz.
अल्लाह हाफिज़ सर।
Allah Hafiz बच्चों.